Alrighty. Welcome once again, everyone. I am really excited to get today's webcast kicked off. My guest for the event is Aditya Kalro. Aditya is a senior software engineering manager at Meta. Aditya and I first connected back in 2018 when I was researching the tech and processes that leading machine learning adopters were using to consistently get machine learning models into production. That podcast was published, that conversation was published via the podcast as episode 197. And what I learned about Facebook's FB Learner Flow platform helped inform the ebook I was writing at the time, The Definitive Guide to Machine Learning Platforms. At the time, FB Learner Flow had been up and running for a couple of years, was run by a small engineering team, and had already seen broad adoption within the broader Facebook engineering team, providing support for machine learning training for use cases like newsfeed personalization, as well as filtering offensive content. Of course, 3 years is a long time ago in machine learning, so we thought it'd be interesting to bring Aditya back to discuss how the platform has evolved since then and how it's added components like a feature store, tooling for data labeling, greater privacy and security, and more. Before we jump in, I'd like to share a quick announcement. We are just 2 months away from TWiMLcon AI Platforms 2022, an event we are super excited about. It's our premier MLOps conference, and we invite you to join fellow ML and AI practitioners and leaders as we explore real world challenges and solutions for developing, operationalizing, and scaling ML and AI in the enterprise. The event is now in its third year, and the conference will once again be back virtually from October 4th through 7th with a wide range of technical and case study sessions, live podcast interviews, in-depth workshops, and panels. We've got a really great program we're developing, and we'd love for you to join us. And new this year, qualified attendees can apply to attend for free by visiting twimlcon.com/attend. If you're working on problems like what we're discussing today and what we'll be featuring at the conference and have an interesting story or journey to share from your experiences, I'd also encourage you to visit twimlcon.com/speak to fill out our CFP, call for presenters, which is open through the end of this week. All right. I'd like to, at this time, welcome up our presenter, Aditya Kalro, Senior Software Engineering Manager at Meta. Aditya, how you doing?
Hey Sam, thank you for having me. I'm doing well. It's been a long time since we connected last.
It's been a really long time. While you're getting your slide set up, I'd like to remind our audience that we'll be taking questions throughout the session. So please don't be shy about submitting them via the chat. My team and I will be in there moderating, and we'll do our best to make sure that we either work them into the conversation or address them at the end of the presentation. Uh, one more thing, Aditya, before we get things kicked off, I've got a budding tradition here with these webcasts to start off with a dad joke to remind us not to take ourselves too seriously. So, my question for you is, what did Yoda say when he saw himself on a 4K TV?
The first thing that's popping into my mind is that there is no try, but I don't think that's the right answer.
The answer is, HDMI.
That's good. That's really good.
All right, over to you.
Hello everybody. My name's Aditya Kaltro. I'm a senior software engineering manager at Meta. I've been at Meta for a little over 7 years. Almost that entire period of time, I've been working on AI infrastructure and AI platforms in some capacity or the other. Sam and I met back in 2018 where we talked about this, which at the time was called FP Learner Flow. FP Learner was already being used by most of the machine learning engineers at Facebook back then, and it was a lot simpler time because we we actually made it simple for ourselves as well. We boiled it down into what is this very simple diagram. We start with raw data that the product teams were responsible for. Everything that we needed to do, training, evaluation, experiment management, publishing, all of it was stuck into this one little training platform, which we call FP Learner Flow. And we were at the time starting to build the inference platform. Think of it as an internal cloud for inference at, at Facebook. Um, a lot of the ML modeling at the time was written in a very bespoke fashion. The ML engineers would have binaries, and we would execute this on our training cluster, which was growing in leaps and bounds because the demand for ML was growing. We had just about gotten ready with the inference platform, and we were about to put it into production. It was based on all of this work was based on great work that was done with the ads team. Some of it was built by the ads team, which we then generalized and made available to everybody. So there was a lot of work left on the platform, and we had to rationalize about even what to work on. And we also left a lot of things over to the ML engineers, which we eventually wanted to take responsibility for. So let me tell you what the philosophy behind FP Learner was. We started with some pretty basic principles. It has to be reusable and composable. Now, what that meant was FP Learner was an execution engine for is an execution engine for a series of workflows. And the way that you define the workflows is using the APIs that we built. The workflows have to be reusable and they have to be composable. Workflows were built on top of operators, and an operator could be anything. It could be one of those bespoke binaries that I was talking about, or it could be another workflow. So you could have nested workflows. This is what enabled us to build stuff like hyperparameter sweeps. You could write a generic hyperparameter sweep and run it on top of excuse me, on top of any of the training workflows that you could think of as an operator. Hence the composability as well. The second thing that we wanted to make sure ML engineers had was tooling that was very easy to use. And this is where we focused on experiment management. This was the hardest part, at least in our opinion, about what we were enabling. So the first thing was, how do you make experiments consistent? How do you make sure that every time you run the experiment, you have access to the same data, you're running on the same type of hardware, and that there are no ghosts in the machine that will skew your results one way or the other? The second thing was the UI and the CLI that we came up with, specifically geared towards experiment management. So being able to search for it, being able to compare different types of experiments and tag them, and even start something like a hyperparameter sweep once your initial experiment was done. Metadata about all of the experiments and AUC curves and metrics became first-class citizens that we wanted to show on the screen for anybody who wanted to see it. This allowed several users who were not well versed in ML to start using the platform as well. So you can imagine an ML engineer writing a workflow, but a UI engineer somewhere down the line being able to just run it and consume the results. And the third thing, which is true of almost everything in Meta, is we needed a massive amount of scale. This was the most infra part of the system. We built on top of an existing scheduler that was capable of executing binaries, and our main contribution was quickly breaking down what we called operators and packaging them so that they could be spread out across the entire system. So the other thing that we also ended up building was caching. Now, with ML, you typically run many experiments that are similar to each other. They're mildly different for you to see which one works, which one doesn't. We cached the results of each of the operators. So think about the composability that I was talking about earlier, and imagine hundreds of operators in a workflow. If you cache all of the results and they build on top of each other, one workflow can use the work that is already done by a different one. And this caching laid the groundwork for optimizing all of the experiments and for any of the future AutoML work that we were doing, including feature exploration and hyperparameter sweeps. We say this was a game changer in terms of how efficient we could be. So that was 4 years ago. Now, how did we evolve? We realized that we focused on training really well. We started working on inference, but there were a ton of other things that we'd left on the table. For example, distributed training was the next big thing that was coming our way. And we started to use specialized hardware at about that time. GPUs became more prevalent. The fleet at Facebook for GPUs became larger. Inference I talked about as well.
Was
The
the
one
specialized hardware the open compute stuff that's been written about?
Eventually, at the time that we were chatting, we were working primarily on GPUs. Today, there's specialized hardware that Facebook is building specifically for AI.
Got it.
Then, sorry, coming back, the one of the big pieces, and I think everybody will see this is and agree with this, is that the main bang for the buck with ML is in data and in features. We had left feature engineering entirely up to the product teams. It was their responsibility to come up with it. We had zero tooling for it at the time. And this was actually a huge opportunity for us. We built two separate pieces associated with feature engineering. The first was a feature store, and I don't mean feature storage, I mean a feature store kind of like an app store where you could connect to different sources of features, and we were the marketplace in between. We put in a bunch of guarantees for that. And feature engineering development, which is actually taking raw data and converting it into features. This is where a bunch of work around compilers and how do you compile down into the different data pipelines came in, several other things as well. Another thing that, as you can imagine, at Facebook is a really, really big piece is being able to label data efficiently. It's a massive amount of data that we have. Being able to do it well, being able to use the workforce well is something that we have to do. Also, there are two pieces to this. One is which is manual, where we actually have people reviewing this, and then the other one which is completely automated, which is what is we enable for personalization, and we built infrastructure specifically to help with that. And the last piece, high-level abstractions with AI platforms for MLOps. This will become a lot more apparent when you see the next slide, because we built a ton of stuff, and these were different pieces of infrastructure. We needed some way, a layer on top to tie all of these pieces together. Some mechanism where you could do feature engineering and fetch your data, do feature engineering, train a model, put in conditions that if your model was better than X in terms of some metric, you could push it up to production. And all of these needed to be easy to use. We learned a lot of stuff along the way. There were a lot of things that were important. The first of which was we needed to treat ML development the same way that we treated software development. Build and release and retrainability were really, really important. This comes back to the consistency of experiments that I was saying about. It became necessary for us to make sure that we were incredibly reliable and people could depend upon us to release on the time that we said we were going to. Also, because people were packaging up their workflows, we needed to make sure that their release was solid as well. Monitoring and debugging became even bigger, not just for the system itself, but actually for the models that were there in production. Lineage. This was the hardest part for us to rationalize because we didn't start with Lineage in mind when we originally started to develop this. And it became incredibly necessary for us because sometimes our interpretation of data would change. Something that was there in production would be different than we originally thought it was. And we needed to trace back every single model that was using that piece, that feature or that piece of data and retrain it. So Lineage became incredibly important for us. Model freshness, as I'm sure everybody who's worked in personalization will know how important this is, and we didn't do enough of this to begin with. And finally, privacy and security. We added a bunch of stuff into all of our systems a little bit later.
And before you
This, oh,
continue, we had a question in the chat from Alfonso, um, speaking to the last point about privacy and security specifically. He's asking about, I guess, the integration between security for ML and the broader security in Facebook engineering, and in particular, are you following a DevSecOps type of methodology there? And if so, how they connect?
yeah, we are. And the internal security team at Facebook has actually been incredibly helpful in plugging a bunch of holes inside of our infrastructure. Stuff like data separation. And how do we actually enable that for specific pieces? For with respect to privacy, how do we make sure that I'll give you an example. The data that should only be seen by a particular model should we can't share it with any other model, right? So how do you create the quadrant of space specifically to be able to do that? These were the things that we spent a significant amount of time.
Mm, great, thank you.
This became well, actually, this is also a little bit old, but this became the diagram that we originally started with in 2018. This is where we eventually ended up. We built, like I said, a bunch of stuff. The feature framework specifically for feature development, AI data, which is the labeling platform that we had. ML data platform was actually a piece that we had to build specifically to be able to read data fast enough for distributed training and for specialized hardware. And then the training platform event that was Flow evolved further in using better schedulers, supporting for distributed training. And the serving piece had both the instance platform and feature store. I didn't mention this earlier, but one of the things that the instance platform did was assumed that the entire all of the features were part of the example that were being sent, and the feature store enhanced that by saying we can go and fetch additional features for your example. You don't have to provide everything from the get-go. And then we built AI metadata, which was our lineage, privacy and security, and the AI platforms, the higher level abstraction that I was telling you about that threads through the entire system. So, if I were to succinctly put what we learned into a slide, we need several components to work together, and the APIs and handoffs between them need to be strong. The system needs to be modular and not monolithic. That was one mistake that we made with FB Learner Flow, and then we eventually ended up splitting it up to the point where even the UI was treated as a separate component and separate piece. Data and feature formats should be standardized across the company. This was a big, big, big deal. I had worked, so it's a fairly small community in terms of people working on AI platforms and infrastructure. And I have friends at other companies who had done this from the get go, which made their life so much easier. Um, and the last thing, which is a, a previous manager of mine used to say this, which I think is very, very apt: disrupt yourself early. And the easiest way to do that for us was to pair our team's engineers with ML engineers from product teams. They were building stuff, sorry, we were building stuff for them, and they were helping us trying to figure out what it was that we needed to build. We always work with alpha customers every time that we're starting something new, specifically to enable impact, to enable and make sure that we're building the right thing.
Referring to the slide that you have up here, when you talk about the data and the feature formats, I'm curious to hear a little bit about what direction you took in standardizing them. What were some of the challenges you ran into, and what were the ultimate formats that you ended up standardizing around?
So, for personalization, we ended up taking Dwarf, and basically it's a tabular format specifically for that we started with, and we edited it a little bit to make it a little bit more palatable for Facebook. But that was where we started, and most of the personalization worked specifically on that. The extensions that we had to work on were specifically for sparse data. And as you can imagine, Facebook has a ton of sparse data in terms of ads, in terms of even feed and a bunch of the other personalization spaces.
Great, great. We've got a question in from Param asking, can you talk a little bit about automatic data labeling and how you've approached that?
So this works better with personalization, and I think the easiest way to explain this is in with respect to interactions is where we can do automated data labeling. So, and this is the purely automated part of it. So, to give you an example, right? You have an event. So we serve a story to somebody, and we have a time window in which somebody can click on that or not click on it, whatever the second event is, and we're able to join this across that those two time slices. This is the pure automation part of it. The second part of it, which is with in terms of manual labeling, one of the things that we actually do is assign a confidence score every time a manual labeler labels something. We ask for a confidence score, and we use that to actually train a machine learning model. We also have we also have a spot checker in some sense. Think of it as somebody who randomly picks out the the labeling done by person X at some point of time to see whether the two different labelers match. And this is another input that we have towards the ML model. So we can automatically try and improve our labeling. And whenever the confidence is around about 50%, we bring a manual labeler in. If it is on either side of the bell curve, like if there's a high confidence, then we would typically try to avoid that being labeled manually.
Got it. I have a question here asking about kind of how the team coordinates using the platform. For instance, what part of the platform is relevant to data scientists versus ML engineers versus infra engineers, and how do the teams collaborate and how do handoffs happen?
So, okay, now that's a
It's a
slightly
big question, right?
it's a big question. Um, so, a large part of it with respect to infra engineers is the people that are building the platform. It's we are the we're people with that are building for the ML engineers and the data scientists. ML engineers typically end up using the Pythonic APIs. ML engineers and data scientists typically end up using the Pythonic APIs that we publish. So there are CLIs and there are APIs that people use to write the workflows and to write what we call domains in the higher level platforms. So, for example, integrity would have a domain. The ML engineers on the integrity team uh, typically have a templated domain, and they clone it and continue to edit it. So, for example, this would be hate speech, the classification of hate speech. There is a very well versed team in how to use these platforms that help people get up and running. And the other part that they use is the UI, which is where all the experiment management occurs. By they, I mean ML engineers and data scientists. Infra engineers are typically the ones who are supporting and are behind the scenes. So handoffs are typically within the teams themselves. So, for example, the integrity team actually has a bunch of ML engineers. They have, or the ads team has a bunch of ML engineers, and they have well established processes within them about how to use these platforms as well.
Awesome, awesome. Yeah, one of my favorite session types that we do at TWiMLCon, we kind of came up with this at the first one, and have continued doing it. Is this thing we call a team teardown? Basically, we get a bunch of folks from these different roles within an organization, within a company, and talk about how they interact with one another. Particularly, a lot of the interesting conversation ends up being around the relationship between the product teams and the platform teams, and how they identify priorities, how they iterate on platform features and capabilities, and everyone seems to do it slightly differently.
Yeah, and I have, like I said, I have a bunch of friends working in AI platforms across the industry, and I think that it. I'll give you an example of an effort that I love. There's something called ProML at LinkedIn, I think,
Mm-hmm.
and they have done a fantastic job of actually putting ML engineers first and try to understand what's going on there and try to build infrastructure for that. We did something similar, but I think that they've tried to move the entire data infra and ML infra organization around that one effort.
Mm-hmm. Mm-hmm. Um, has the I'm curious around like adoption of the platform, and back in 2018 it was already fairly broadly adopted within Facebook engineering. How has that changed? Are you know are there other platforms that folks are using? A lot of companies have kind of come out with these lower level platforms, and then as folks get more specialized needs, they'll have higher level platforms, and so maybe a forecasting team doesn't necessarily use FB Learner anymore. They're using some higher level platform that might or might not use FB Learner Flow.
The That's a really good question. The the truth is that FP Learner Flow is low level enough
Mm-hmm.
that it actually became the base for a bunch of things. We built a bunch of higher level platforms on top of it. So the AI platform that I was referring to is actually built on top of FP Learner Flow. The it also FP Learner Flow also ended up evolving. So we added distributed training into it. So the ads team has their own flavor of AI platforms that generate FP Learner Flow workflows and execute on top of it. I think that we went a step further when I said composable. It's not just that um, the workflows are composable, the platform's composable as well. So you can
Mm-hmm.
plug in pieces using the APIs that we built specifically to enable this. To give you an example, the inference platform that we have that's generic across the entire company is used by 90 plus percent of the teams, but the ads team has their own specialized inference platform, and that works really well for them because their scale requirements are very different from everybody else's. So also they were a very well established team, but the publishing from FP Learner Flow works with their platform as well. And this is what I mean by composability. The other thing that you kind of mentioned was a lower level platform. This is exactly how PyTorch ended up inside of FP Learner Flow. So we have a PyTorch operator that people can write their entire PyTorch work, their neural network into, and this executes on FP Learner Flow. We figure out how to package it and distribute it across the entire fleet.
Awesome, awesome. Um, I have a question from Eugene asking about containers and the way you think about the role of containers when designing a platform from scratch versus just deploying services on top of the host OS. If I remember correctly, what you were doing kind of predated the maturity of Kubernetes, and you already had a very large landscape, and so you didn't use anything off the shelf in that way. Can you talk a little bit about that level of your infrastructure and how things work?
Yeah, at the time you were right. You're right. We did not have containers. We still don't. Although we are moving towards containers now. It's an internal homegrown solution for containers, but it follows. No, sorry, not follows, but it is spiritually very similar to Kubernetes. The additional reliability and security that containers bring, I think, is very useful. And if you're building something from the ground up, I'd suggest starting with containers if you can, because it will make life easier both for distribution of software and from a security and scalability perspective.
Awesome, awesome. I've invited folks to come on stage to ask their questions live, and we have a taker on that, Zach, who I'm going to call up here.
Hey
All right, go
guys.
ahead, Zach.
Hey, Zach.
Thanks, Sam, for hosting this. So I was going to ask about, it seems, I like the idea of standardizing data and features across the company, but this also seems like something which is pretty difficult logistically to execute. And I was wondering how you went about that. Did you have like large meetings? Did you use design docs? Did you use some sort of focused Slack channel? Um, yeah.
Um, Actually, design docs, large meetings, and we don't have Slack, but we do have an internal version of Facebook called Workplace that was very actively used in trying to standardize on this. I think the one thing that helped in the personalization space was that we started early, and that the framework that we use for personalization became more actively used across the entire company. That made it easy for us in personalization, but it pretty much in anything else, it became fairly fragmented. So it is still fragmented, but one of the things that ends up happening is the higher level AI platforms that I was talking about, we did standardize on a data format, and that anybody who uses that AI platform ends up using that data format. We've I think that we don't have one data format to rule them all even now, but there are some that are very widely adopted. Maybe four or five of them that basically make up the bulk of the data formats that we have.
So it sounds like you've got some popular formats, but it's also very use case specific.
Not exactly use case specific. I think that it's we've got some popular frameworks,
Mm-hmm.
and those frameworks specify the format to use.
Got it. Got it. Awesome.
Thank you.
Thanks, Zach.
Sure.
Anyone else? Go ahead and raise your hand. We've got a question here from Han. Are there significant differences in building ML platforms to support more research focused work? For example, large language models versus more product focused work. Do you support both of those teams? And if so, what are the
Yes.
differences?
Yes, we do support both of those teams.
Great
There
question.
are differences. It's a great question. I think that the main difference is how iterative research is versus how stable a production model needs to be.
Hmm.
So, for example, Facebook AI research was a lot of people were much more comfortable with something like Slurm, and we ended up having a Slurm like CLI on top of FP Learner Flow specifically to enable them as well. There's also an internal deployment of Slurm, by the way, in inside of Facebook for various reasons. But the most important reason is that researchers tend to work significantly faster, and their requirements for uptime are very, very different from something like ads or feed. When you think about distributed training, for example, we had to worry about the workflow running for several days. Now, if you actually do the compounding effect of reliability and even one of those machines failing, this would bring the entire cluster down. Whereas in research, people were able to restart from a checkpoint without losing too much. And that's what made a significant difference in the philosophies, even.
What kind of validations and versioning are supported by the platform when tackling model freshness to prevent bad models from being served?
There is, so for example, the inference platform actually does a ton of versioning. We sometimes have multiple versions of the same model running in production, and we use the latest keyword to direct to that model. The feature store also has versioning built in for features. It There is both validation in term automated validation in terms of shadow modes. So for example, you can compare your existing model by shadowing traffic. Sorry, compare your new model to your existing model by shadowing traffic and comparing results. We've enabled that as well. And there's a slow ramp up of traffic to the newer model, just in case people see something that's different. So when you release something to production, it takes sometimes an entire day for all of the traffic to go to the new model. And there is a kill switch at any given point of time so that you can stop it.
And do you support different kind of methodologies for deploying new models and doing online testing and ensuring, in terms of traffic routing for the new models when they're going into production, or is there a single standard that you're using?
There are two standards. There's that are used at Facebook. There's something called quick experimentation, which actually, as you can imagine, experimentation is a big part of the culture at Facebook in terms of any feature that we release, and we use
Mhm.
that pretty extensively for models as well. So you can create a quick experiment and expose a small amount of the production traffic to a new model to see how it does. Um, I want to make sure that I answered your question, Sam. This was more in terms of experimentation and sending live traffic to it, but you talked about deploying as well, so I want to make sure that I understood your question completely.
I wasn't so much asking about experimentation as much as you've got a new version of a model, you want to deploy it, you want to kind of dial up the amount of traffic it's receiving to make sure it's working before you kind of totally swing over. There are different strategies for the way you might approach that, and I'm wondering, yeah, how you do it.
There's actually a lot of stuff baked into the quick experiment mechanism. I think I don't have as much information about that, but basically there are multiple strategies that people
Hmm.
end up using,
Yeah,
and uh, I can try and get more information for you on that, but I don't have it at the top off the top of my head.
got it. Got it. Looks like another question from Zach.
Hey, I was wondering, so it looks like some of the times you guys build your things in-house, sometimes you're using more open source solutions. And I was wondering, when you choose to build things in-house, do you feel like those end up being the right decisions? Or, a lot of times it sort of makes sense in the beginning, but maybe things change over time as new open source solutions come out. And whether or not you recommend, or what recommendations and advice you would have for companies about designing something in-house, building something in-house versus choosing an open source solution.
Yeah, if
Personally,
I
I'd
could
say
tack on to that, yeah, at the time you started these efforts, there wasn't really anything that you could use open source, and so um, a lot of folks that I talk to, have this response like, "Hey, if we were starting now, we might do it a little bit differently." And I'm curious, as you're answering Zach's question, if you'd reflect on that as well.
so. Um, I would say try open source first. If there's already something that you can build on top of, then it's probably better, and you also get the support of a large community, hopefully a large community that would end up being significantly better than trying to do everything in house. That's actually how PyTorch kind of. I know that Facebook is a big proponent of PyTorch, but it was already something that was out there, and we helped it grow larger, and we contributed back to it quite significantly. So, at the time, Sam, to answer your question, at the time there was no equivalent to this. There are a bunch of equivalents now. I think what ended up happening with us is we ended up building a lot of Facebook specific stuff and Facebook specific optimizations into all of these systems. So even if we were to change right now, it would, we'd end up having to build a lot of stuff on top of anything that's open source. That being said, to answer there, I'll give you an example of where we're trying to do something better. We have an internal implementation of trees and random forests, and we are actively trying to use an open source alternative. Um, Partly because of extended support, partly because out there things have now caught up to in terms of performance, in terms of ease of use, even.
Mm-hmm. Great. Thank you.
Thanks. So you mentioned that most recently you were sort of realizing that you needed a feature store. Did you end up open sourcing, like using an open source solution for that, or did you build something in-house?
So actually, the feature store started back in 2019, and this was, as far as I know, we were maybe the first or the second company to start working on feature store.
Cool.
Also, I want to be very clear about this. Our feature store is an app store more than a storage solution. So it connects to different storage solutions that store features.
You mentioned that earlier. The the idea you're trying to convey there is that it's primarily focused on solving problems like feature discovery and reuse as opposed to like point in time correctness of features and that kind of thing, or is it also doing point in time but just it's not a data store itself?
It's also doing point in time, but it's not
Okay.
a data store itself. So for example, the main problem that we saw was I think I don't remember who it was that had asked it, but somebody had asked about versioning, and I mentioned that Feature Store does versioning as well.
Mm-hmm.
That actually became a huge problem for us because we were connecting feature users with feature creators. And as you can imagine, there are some things that are fairly reusable
Yeah.
in terms of features across the company.
Yeah. Question from Facundo. I was wondering if there's any model packaging approach that works better uh, relative to containerization. So, how are you packaging models? I guess maybe is the question.
Most of the time, we use whatever PyTorch has been pushing, and that's what almost all of our models are almost exclusively PyTorch now.
Okay.
And with trees and a few other things, there's an internal packaging mechanism for trees. If I remember correctly, we use Mirkwood Forest, and I think the others are all whatever the open source equivalent of the packaging is. For distribution, we actually have an internal FPPKG, which is our mechanism of being able to distribute across the entire fleet.
Okay. Can you talk a little bit more about the data labeling tooling that you've built and the labeling process overall?
The labeling process, so there are several manual labelers that are there inside of Facebook. Now, for example, and typically what ends up happening is we have not exactly a process, but basically a policy that's set up for let's say like using hate speech. That's probably my favorite example. So we have a policy that's set up for hate speech, and posts at random are assigned to labelers using the data labeling fleet that we have. There are also the layers associated with this. What we ended up building into the data labeling infrastructure was pluggable modules. So, for example, the integrity team wrote their own pieces of these pluggable modules, and today the data labeling um, tooling is owned by the integrity team because they use it the most. So those pluggable modules became more extensible. Now we ended up doing a bunch of stuff for computer vision, and every time the a particular task would get assigned to um, to a labeler, these pluggable modules would start to come up. So, for example, in the captchas, we've seen this, right, where you have um, identify trees, for example. We built a bunch of stuff around being able to draw bounding boxes and layers on top of the images themselves to be able to identify that. Two or three things ended up happening because this is a concerted effort among a large team. There are supervisors that create these tasks and they assign it to a bunch of reviewers. These reviewers are actually around the world, and it's our responsibility to distribute the task among the queues that are assigned to each of the reviewers.
Mhm.
Then, once the labeling is actually done, I mentioned that there's a spot checker who will randomly pick out the labeling tasks done by a few people to make sure that things are going in the right way. This is also how we actually tell whether or not the reviewers, whether the labeling of the reviewers is up to stuff. And it's the checks and balances system that we basically put in place. By the way, I'm speaking. This is I'm speaking for another team that actually came up with all of these processes. It wasn't my team that came up with these processes. We helped build the software, for example, the bounding boxes and all of these other things that I was telling you about.
Okay. Okay. Has the boundary between data eng and ML platform evolved or shifted over the years, or has it been pretty static and well defined where one stops and one ends or begins?
No, it has changed and moved around quite a bit. I think the easiest example to give you is with feature engineering.
Mm-hmm.
So with like I said, we ended up compiling down the higher level feature definitions into data pipelines, and we ended up working with the data infrastructure team quite significantly in order to enable that.
Mm-hmm.
There is real time features and batch features, which is basically what's offline. Though there are two different data infrastructure teams that we ended up working with specifically to enable that as well. The line moves back and forth. Let me put it that way.
Mm-hmm.
But I think we've come to a happy balance.
Got it. Got it. A question about the frameworks that are used to define things like models, feature transformations, interacting with inference and scoring APIs, things like that. Are you doing anything standard like Onyx is referenced here as an example, or is it all custom? Something that LinkedIn is using called Quasar is also referenced here.
There are a bunch of things that end up getting used, particularly around. So Onyx was used quite extensively
Mm-hmm.
at the time, and it was there is there is some standardization, but not enough. I think the one standard that we've all gotten ourselves around is PyTorch. So typically, what ends up happening is whatever it is that PyTorch is pushing is what we end up trying to use as well. So that's the safest bet because PyTorch and neural networks have become the de facto standards for modeling at Meta.
Got it. Um, Maybe along those lines or related lines, are you doing anything with compilation? So compiling models for specific types of hardware?
Yes, there's a bunch of optimization and transformation that we do specifically for different types of hardware. Mobile is a good example. Oculus is another example. GPUs, like I mentioned. There, there are teams. So optimization actually goes across several teams. There is one part of it that's on my team where we're working specifically on GPUs. There
Mm-hmm.
is a significant part of it inside of the PyTorch team because, as you can imagine, the compilation that they do is applicable to the entire industry. And
Mm-hmm.
then there is the hardware team at Facebook that we collaborate with quite significantly. This is apart from the product teams, but the hardware team that we collaborate with quite significantly to make sure that it compiles down. So the I sorry, I can't remember the name of the team at the moment. It's slipping my mind. But there was the AI software hardware co-design team that had built a bunch of compilers, and I think which are open sourced also.
And so in the case of a team that is working on a model that eventually needs to go on specialized hardware, whether that's Oculus or mobile or something else, how does that last mile, if you will, get integrated into the platform? Are they just kind of running their experiments and, where you might otherwise kind of push button deploy to the serving infrastructure, they have to then manually walk that through a compilation process, or has that part been integrated into the workflow as well?
So it's integrated into the workflow. So let's take Oculus as an example, right? And this is completely hypothetical at this point. But what the Oculus team could end up doing is write an extra operator into their workflow specifically for model optimization. And this is actually how it's done, where model optimization is a step inside of their workflow. Now, this step evolves as hardware evolves and as better techniques come in. We are exploring how to automatically do optimization as well. So you can apply multiple techniques and see whichever one works. So there's an like a hyperparameter sweep, you now have an architecture sweep and an optimization sweep as well.
Got it. Got it. All right, we've got time for another question or two. So if you've got some questions that haven't been answered yet, drop those in the Q&A or the chat. Next question from Matea. How do you approach model evaluation? Do you use open source tools or your own platform? And how do you approach automating it, or do you have advice on automating it?
We have built a bunch of tools. So the model evaluation is actually one of the things that is also specific to hardware. So if you're going to do CPU versus GPU, your model evaluation tooling needs to account for that. We built a bunch of bulk evaluation tools where you could take an entire table and give it to your evaluator, and it would spit out another table with the results. That became our mechanism for offline evaluation. Um, the we don't use too much open source here because evaluation actually also predates a significant portion of the open sourcing. Sorry, predates a lot of the open source that was happening at the time. Um, I want to make sure that I answered all of the pieces of the question. There were like 3 or 4 pieces to that question.
Just how do you approach evaluation in general, open source and automation?
Automation is actually the most is the part that we're working on the most, which is we bake it into our workflow. So we do the train test split automatically when we point at a particular data table, and eventually use that for evaluation for the test. Subsequent to that, like I said, we have bulk evaluation and online eval. The same model is used in production for inference and for offline evaluation or bulk evaluation. As far as possible, try and use the same model so that you basically offset any skews.
Mm-hmm. Um, can you talk a little bit about? You mentioned that that Lineage ultimately became important, and you had to build quite a bit around that. Can you talk a little bit about what you built to support Lineage and some of the ways it's used?
So one of the things that ends up, I'm pretty sure that everybody knows about the graph, the Facebook graph, and the infrastructure that we ended up using for representing the graph of users at Facebook. This is called ents. We actually started to use the same mechanism for Lineage at Facebook. So you can connect different entities, and we could have, so for example, workflows could be an entity, a model instance could be an entity.
Oh
What
wow.
features that uses could be an entity. What the data source was could be an entity, and we were able to arbitrarily draw connections in between all of this. So you can basically be dropped anywhere inside of that graph and follow it all the way back or go all the way forward. That was the mechanism that we used to create the lineage graph. It it is. We got a bunch of advantages because it was blessed Facebook infra. We got all of the backups, we got massive amount of scale, and it became just very useful for us to be able to traverse it.
Awesome. Awesome. Uh, all right. Well, that is going to be a wrap on our session. The recording of the discussion will be available on YouTube, and we'll be sure to send out a note so that you know where to find it. Please be sure to share it with folks that you think might be interested. Uh, Big thank you to you, Aditya. Great to catch up once again and hear about the evolution of the platform. Sounds like a lot of amazing work went into that. Thanks so much for participating.
Thank you so much for having me. It was great to meet with you again, and thank you for all of the questions from the people who were watching.
Yeah, thanks so much, everyone, for all of the great questions. If you enjoy conversations like this, of course, check out the podcast. Check out TWiMLCon, TWiMLCon.com for information about our conference. We'll be hosting a lot of conversations like this with a lot of folks doing amazing work in the field. Thanks for joining.